Okay, so on notes 5, 6, we're going to be using the quadratic formula to solve a quadratic equation. So it says some quadratic equations cannot be factored. So the quadratic formula is just another way of solving your quadratic equation. So we've already talked about standard form here. So if you look here, it says if ax squared plus bx plus c equals 0, then you can use the quadratic formula to solve. The quadratic formula is x equals a negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so your first step when you're using the quadratic formula is to make sure that it's in standard form and make sure that it's set equal to 0. So on example 1, the first step would be to add 7 to both sides of your equation. So you have 3x squared plus 13x plus 7 equals 0. So there's our equation. We're going to find a, b, and c, so that way we can plug into our formula. So a would equal 3, b would equal 13, and c would equal 7. Okay, so we're going to plug into our formula. We have x equals, notice on the formula it's negative b is 13, so that would be negative 13 plus or minus the square root of b squared, so 13 squared, minus 4 times a, which is 3, times c, which is 7, and that's all over 2 times a, which is 3. Okay, so we're going to find the number that's under your square root first. So you're not typing anything into the calculator, you're just finding what's under the radical. So you can actually type that in if you want to find that number. But 13 squared would give you 169. And then that would be 12 times 7, which would give you 84. So minus 84. And so you should get, that would give you 85. Okay, so I'm just going to rewrite this as x equals a negative 13 plus or minus the square root of 85, and that's over 6. Okay, so after you find the radical, the number under the radical, which is your radicand, you're going to see if you can simplify it, and notice 85 is not a perfect square, but you need to see by using the factor tree. So 2 will not go into 85, 5 will, 5 times 17, and then notice those are both prime, so we wouldn't be able to simplify that answer there. Okay, so that would be our solutions, because a positive or a plus and a minus would give you 2 solutions there. Okay, so looking at example 2, notice that it's already in standard form, so we're going to go straight to finding a, b, and c. So a would equal, notice the coefficient of x squared is 1, b would equal negative 5, and c would equal positive 6. So we're going to plug into our formula. So x equals negative b, and b is already a negative, so that's going to make it 5 plus or minus the square root of negative 5 squared minus 4 times a times c, and that's all over 2 times a. Okay, so at this point, you're finding the number that's under your radical. So negative 5 squared would give you a positive 25, and then 4 times 6, you get minus 24. So this is the same thing as 5 plus or minus the square root of 1 over 2. So after you find the number under the radical, see if you can simplify it. Notice that 1 is a perfect square, so we can take the square root of 1. It equals 1. So if you can actually add them together, you need to work it out and find the 2 solutions. On example 1, we weren't able to add 13 in the square root of 85. So we need to actually separate it into 5 plus 1 divided by 2. And 5 minus 1 divided by 2. So you're going to get 6 divided by 2, which is 3, and then 4 divided by 2, which is 2. So x equals 3 and 2. So again, if you can actually work it out, make sure that you're finding your two solutions. Okay, example 3. Notice it's not in standard form. We need to set it equal to 0. So I'm going to add 15. So you have x squared minus 3x. Oops. Plus 15 equals 0. So we're going to find a, b, and c. A is 1, b is a negative 3, and c is a positive 15. Okay, so we're plugging in x equals a negative b. B is already a negative, so that will make it positive 3 there. Plus and minus the square root of negative 3 squared minus 4 times 1 times 15 over 2 times a, which is 1. So from here, we're finding the number under your radical. So that's going to be negative 3 squared is 9. You're subtracting, that's going to give you minus 80. So that should be 60. So 90 minus, or 9 minus 60, which would give you a negative 51. Okay, so I'm rewriting that. That's x equals 3 plus and minus the square root of negative 51 over 2. Okay, so we've already talked about when we get a negative under the radical, that's imaginary. So we're going to bring that negative on the outside and make it an I. And then we have the square root of positive 51. So you need to see if you can simplify that square root of 51. You will not be able to simplify that. It's not perfect, and you won't find any pairs in order to simplify that. So that would be your answer, because we won't be able to add or subtract those together. Okay, the next part, anytime you have a quadratic equation in standard form, you can find the discriminant, which is, actually, if you look at it, the discriminant formula is b squared minus 4ac. Notice that is your formula that's under your radical. If you find what the discriminant equals, that will help you with finding what type of solutions you will have. So it says if your discriminant, which is b squared minus 4ac, is greater than 0, so that means it's positive. If it's positive, that means you're going to have two real solutions. Notice on the next part, if it's negative, which is less than 0, you're going to have two imaginary solutions, just like what we did on 3. We ended up with a negative under the radical. That made it imaginary. And then if your discriminant, which is under the radical, is 0, that means you only have one real solution. If your b squared minus 4ac, which is your discriminant, is a perfect square, which we had on number 2, then the equation has real rational solutions, so no square root, like we had on number 2. Okay, so knowing that information, let's look at an example. We're going to find the discriminant of the quadratic equation, and then we're going to give the number and type of solutions of each equation. So let's look on part A. We need to find A, B, and C. So our A on part A is 5, the B is 7, and then the C is negative 3. We're going to plug into our discriminant formula. So that's going to be 7 squared minus 4 times A, which is 5, times C, which is a negative 3. Okay, so squaring 7, you get 49, and then that would give you a positive 60, so that would equal 109. Okay, so we just went over if it's a positive number, that means you will have two real solutions. Okay, let's look at part B. A equals 9, B equals 6, and C equals 1. So plugging into your discriminant formula, B squared, so 6 squared minus 4 times A, which is 9, times C, which is 1. That's going to give you 36 minus 36, so that would give you 0. When it's 0, there's only one real solution. The reason for that, if I looked at an example right here, just say it was 2 plus or minus square root of 0 over 1. Just say that was our solution there. The square root of 0 is 0, and the reason you would only have one solution is because when you add or subtract 0, you're still going to get that first term that you're adding or subtracting the 0 from. Okay? So that's only going to be one real solution. Okay, C. Notice A is 1, B is also 1, and C is 1. So we're going to do B squared, so 1 squared, minus 4 times A, which is 1, and C, which is 1. So 1 squared is 1, minus 4 times 1, which is 4. So you get negative 3. If you get a negative for the discriminant, which is the number that's under your radical, you're going to have two imaginary solutions. Okay,